Okay, so we talked about measures of center, mean and median. They throw a mode in there. It's not technically a measure of center, but it is a measure of stats. So we also have measures of spread. Talks about how spread out our data is. So we start off with dot plots and histograms. So now we're getting into box plots. These are all ways of displaying data. They're just kind of useful in different scenarios. So dot plots, if you have a smaller set of discrete data, then that's when it's more useful. Histogram, if you have like a wider set of data or larger set of data, especially if it's something continuous, that's where you want to use a histogram because we have an interval. We can go, from 2 to 3 and include every little thing in between. Now, when we get into box plots are just a 5-number summary of a data set. Okay, so we're looking at 5 main things to make up our box plot. You may have also heard these called box and whisker plots. Easiest thing when we're starting with a box plot, the smallest and the largest numbers. So our minimum and our maximum. Okay, that's the easiest place to start. Now, when you're coming up with a box plot, when you're coming up with these inner 3, so when you're coming up with these 3 lines right here, that is where you are going to think your little mantra is going to be median, median, median. Okay, that's how we come up with what is called Q1, Q2, and Q3, quartile 1, quartile 2, and quartile 3. So the first quartile is going to be our smaller of the 3 numbers. The third quartile will be the larger. And our second quartile is also our median. Okay, but a box plot, again, it's a 5-number summary. So 1, 2, 3, 4, 5, you'll get 5 numbers. But what those numbers do is they split it up into quartiles or quarters. So, meaning 25% of my data is in here. 25% of my data is in here. 25% is there. And 25% is here. So 100% of our data, but it kind of lets you see the spread. So see, we have 25%, so the same amount of data is here as it is here, but we can see it's closer together. So we have, if you're thinking about the shape of a histogram, so look at this half compared to this half. So here it's tighter. So I would say this is probably this is skewed left, because notice how the spread on the left is a little bit wider than the spread on the right. So our left half of the data is a little bit wider than the right half. All kinds of stuff that you can see just by analyzing different types of data displays. So when we look at we're given some data. So it's going to have us make a double box plot comparing mine and Mr. Nick's class sizes. So we are going to make a double box plot. Now notice, here's my nice number line. I kind of already set it up a little bit. And I have a lot of room up here because I'm going to make a double box plot, which means I'm just going to have 2 of these box plots, but utilizing the same number line. So back to our mantra, median, median, median. So in order to find the median, the middle, well, what do we have to do first? We have to list everything from least to greatest. So we're looking at my class sizes. I've got 19, a 20, and a 20. 23, 24, and 36. These are last year's class sizes, and yes, I did have a class of 36. All right, so I'm going to do the same thing for Mr. Nick. Let's see. Smallest is 25, 27, 29, 31, 32, 34, and 37. Okay, so median. Let's go. So first, I listed it from least to greatest, so I already know my smallest class is 19. My largest is 36, so there's 2 out of my 5 data summaries. So now I'm going to go ahead and find my median. So work my way inside. Now, what happens when your median is between 2 numbers? You need to find, well, what number's in between. So I need to find the average. So 20 plus 23, 43 divided by 2, is that 21 and a half? Yeah. So 21.5, there's my median. Now, if you come into the special case to where your median is in between 2 numbers, when I'm finding Q1, I'm going to, the number that's on the left is going to go with my smaller set of data. The number on the right goes with the larger half. So when I find my Q1 is 20. And when I find my Q3 is 24. All right, so there's my data set. So I'm going to go ahead and set up my box plot. So my minimum is at 19. My maximum 36. Q1 is at 20. Q3 is at 24. And Q1 21.5. So I connect my box. And way out there is my little straggler. Okay, so we'll do the same thing for Mr. Nick. So if you want to pause the video and do it yourself, by all means. If not, you can follow along with me. So again, we see his smallest class is 25. His largest is 37. And then we're going to work our way in and find that our median is a nice 31. All right, so there's my median or my Q2. Now, when I only have one number, when my median is one number, then I completely ignore it. It does not belong to the lower half or the upper half of the data, so it stands alone. So I just focus on these 3 here. So when I come over, my Q1 is 27, and my Q3 is 34. All right, so let's go ahead and set that up. So minimum of 25. Give myself a little bit more room. And maximum 37. Q1 at 27. 31. Oh, that's Q2 and 34. It's my Q3. All right, and I'm going to go ahead and label these since we're both using the same number line. Now, what can we tell just by looking at this? Well, I know I need to go back and answer my questions, but just by looking at this, I see that my data is very skewed. Notice, look at this beautiful little 50% of the data, nice and clustered, and then I have this huge gap over here. So my data is definitely skewed to the right. It's got that it's still only 25% of my data that lives here. However, it's way far apart. Whereas Mr. Nick, if we look, he's pretty darn symmetrical. So that's nice to compare those two. So you can still tell the shape of the data display. Whether it's dot plot, histogram, you can tell it by looking at a box plot as well. So let's see. It says 75% of Senior Nick's classes have at least how many students? All right, key word here, at least. So at least how many? So is that number and above or that number below? So 75% of his students or classes have at least how much? Well, remember, each one of these pieces is 25%. So at least 75% of his classes have how many students? So if I'm looking, all right, so if I'm thinking, well, I've got 75% here. So at least 75% of his classes have 27 students. Does that make sense? So 27 or more? Or should we be looking at this one? 34 or less. So at least 75% of his classes have at least how many students? So what are you guys thinking? If I look at this, I'm thinking 75% have at least, meaning like a minimum of 27 students. So I would look at it this way. So at least 27 students. All right. The median of the upper half of Miss Rompre's data is. All right, so there's a couple keywords here. So we're looking at median, yes, but the median of what? The median of the upper half of my data. So remember, 25%, 25%, 25, 20. So the median of the upper half. So I'm just focusing on the upper half of my data. So where would the median of the upper half be? So of this 50%, where's the median? Our Q3. So the median of the upper half of my data is 24 students. Are there any outliers in our data sets, and how can we accurately determine this? So are there any outliers? Somewhere I want you to make yourself a note, because up till now you guys are like, hey, it looks like it doesn't fit. It's an outlier. Well, there's actually a rule. So when you're determining whether something is a true outlier, it is outside of 1.5 times the IQR. So if you don't remember, the IQR is our interquartile range. It's the range of the inner quartiles. So interquartile range. So looking at my data, who clearly looks like the outlier? Hopefully you're looking at this and saying 36. But let's go ahead and prove it. So how can we accurately determine this? Well, first I want to find what's my IQR. So my IQR is the difference of Q3 and Q1. So my third quartile, so 24 minus 20 is 4. So 1.5 times the IQR, so 1.5 times 4 equals 6. So what that's saying is an acceptable data range falls within 6 units either above or below Q1 or Q3. So our minimum is 19. So is that within 6 units of our Q1 of 20? Absolutely. It's right next door. However, when we look at 36, so at 24, what is the last acceptable number in this data set that wouldn't be considered an outlier? 6 above. So 30 is the cutoff point to not be considered an outlier. Obviously, 36 is well outside this. So, are there any outliers in our data sets? Obviously, it's 36. And we prove this by taking 1.5 times our IQR. So again, anything that fell, I put that at 31, didn't I? Should be at 30. So anything that falls within 30, this is all acceptable data here. Anything above that, that is where it becomes an outlier. So measures of spread. We have 2 measures of spread. We have the interquartile range, which we just talked about, and we have standard deviation, which we're going to get more into next week. So when you want to use the IQR, it represents the middle 50% of the data. Okay? Now, the standard deviation is the typical distance from the mean. So typical distance from the mean. So I want you guys to think about measures of center. When did we use mean versus when did we use median? So if the data was nice and symmetrical, we would have used our mean. So standard deviation goes right along with mean. So our standard deviation we want to use when our data is symmetrical. We also call that normally distributed. Okay? So our interquartile range, that represents the middle half of the data, we use this when it's data like mine, when it's data that's skewed. Okay, because the standard deviation is the typical distance from the mean. So if we have skewed data, if we have data that doesn't belong, well, that's going to make this way less accurate. So that's when we would go to interquartile range, because standard deviation would be a more accurate measure. However, if we have data that's skewed, then those outliers that are included in the data will totally mess it up. So that's when we go to the IQR, which kind of ignores those outliers. So let's look at this double box plot. So feel free to pause the video if you want and answer these on your own. It says, which city has the larger median noon temperature? So keyword, median. So let's go ahead and find our median, right smack dab in the middle. So who has the larger median? I'm pretty sure that's definitely going to be B. How would you describe the shape of city B's distribution? Okay, so when we're describing the shape, so first, let's go ahead and look at our middle half of the data. So you can see, again, this is both 25%. However, this side is more tightly clustered. So just by looking at this, I'm going to say this is skewed left, just by looking at the middle 50. However, if I look at the upper 50 versus the lower 50, that is clear as day skewed left. Okay, it's the same amount of data on each side, but you can see the spread is much larger in our lower half than our upper half. Which city had noon temperatures with a larger IQR? Okay, well, this one we got to do a little math. So the IQR of city A, let's see, looks like goes from 70 to 77. So 77 minus 70 gives us an IQR of 7 versus city B, 75 to 82. So 82 minus 75, thinking 7. So which city had noon temperatures with the larger IQR? Either. They're the same. Which measure of spread would most accurately describe city A? All right, so we're looking at city A. So when you're deciding which measure of spread, IQR versus standard deviation, which again, we're going to talk more about next week. So which would be more accurate? Which one would describe it better? Well, city A, is it symmetrical or is it skewed? So compare that left half to the right half. I'm going to say it's definitely skewed. I would say this one is skewed right. So which measure do we use when it's skewed? We use that IQR, that interquartile range. All right, at least what percentage of the temperatures in city B are above 75 degrees? So let's go ahead and find that 75 degrees. So city B. So here's our 75 degrees. So at least what percentage are above 75 degrees? Well, 1, 2, 3 sections. That gives us 75%. Blank percentage of temperatures are less than 70 degrees in city A. Okay, so city A, let's go to our 70 degrees. So this little piece right here. So again, it's split up into quarters. So what percentage are less than 70? 25%. All right, I hope that gives you guys a good overview of box plots. Feel free to let me know if you have any questions. Good luck. Have a great week.